So this is the practice that we would have done yesterday. Essentially, when you're doing scientific notation, not essentially, what you have to have it be is a single-digit number, and then a decimal point, and then however many other numbers that you have. You guys are going to do this next year with science with significant figures, it's called. But the bottom line is we need to figure out what we need to do to make, oh, this is going to look really bad, to make this spot be where the decimal is, okay? And you have to think about what direction is the decimal going. Is it going to the left or is it going to the right? So if we wanted to make that 9.4, that's better. If we want to make that 9.4, because that's what we need it to be, how many places is that decimal going?
3.
It's going to be going 3. So it's going to be moving from here to 1, 2, 3. Now, is that number getting... Is that number going from small to big? Yes. Okay, so let's look at what that would be. So it's from small to big. From small to big. I'm going to move it over 3 spots. So that means that I'm going to have 9.4 times 10 to, it's either going to be 4, sorry, we did it 3. It's either going to be a positive 3 or a negative 3. So, yes. Because we moved the decimal place 3 spots. You're correct. So we moved it that many spots. Now, if I had 9.4 times 10 cubed, think about what that would be. Wouldn't that be this way? 9, 4, that one?
Yeah.
Is that what we started off with? No. So we need to make our negative. It's going to the negative 3. It's moving over to the left. Think of a number line as well. When you have a number line, when we go to the right, it's getting bigger. When we go to the left, it's getting smaller, right? Okay, so this is going to be stuff that is going to be going on a lot of things that we've learned in the past and just putting them all together. So small to big is going to be negative. Small to big is going to be negative. Now we have this guy. We are going to be moving it over to the right once more, so it's getting bigger. So we know that our exponent is going to be negative. Beautiful. And we just have 7.19 times 10 to the, how many times did it move?
-1.
Just moved over -1. Thane, do you need to move forward? See ya. Because I don't know if it's a focus thing or if it's like a, yeah, move up here. That'd be fine. Because I want you to be able to see my beautiful handwriting.
It really is pretty.
Isn't it, though?
Not as good as mine.
Well, nothing is as good as your handwriting. Even the Declaration of Independence, which is handwritten. Yes?
Do you always want to get to a whole number, so if there's like 100 zeros in front of it, it's to 100?
Exactly. Like the video that we watched yesterday was always a single-digit number, and then a decimal, and then however many decimals were significant. Okay. Now we have this guy. We have 283. Now I'm moving from this spot to, that's a huge, there we go, 1, 2. I'm going that direction. So I'm going to 2.83 times 10 to the, I'm getting from big to small. So it's going to be a positive exponent. The video, they're giving you a lot of background information as well. This is the Cliff's Notes version of it, yeah.
Why would you do that with 283? It's like a lot simpler than that.
When we're going to be multiplying and dividing different numbers, you'll see why. But essentially, the video that we saw yesterday, there are huge numbers out there that this is a way that you can manipulate them and adjust them without having to write the whole number. Okay? Yes?
Wouldn't you do like
0.283 times 10 to the third, that would be this.
What is this?
0.283. Then we wouldn't have the scientific notation where we have a number in the ones digit. It's going to be a number in the ones digit. Always. Then we have this guy. That guy's really close. We just move it over that direction. And we have 2 times 10 to the -1 because it's going to the right. And if we're going backwards, we go to the left. And speaking of going backwards, let's look at the other direction. Now we're writing in standard notation. So we are going to rewrite this number here. And this is a positive exponent. It's a positive exponent. So I'm going to put like a dotted decimal right here so I see where it was. Now I like going in this direction because whenever I have a... oops, that's not where the decimal is. I'm sorry. That's where the decimal was. I need to move it just 4 spots to the right. Done? Thank you. I need to move it 4 spots to the right. And because I have 2 decimals there, that means there's going to be 2 zeros. So I go 1, 2, 3, 4. Now there's my new decimal. I have 2 new zeros, and I'm just going to rewrite it. You don't have to rewrite it, but I'm going to write it for demonstrative reasons. And there's my new number. I'm going to add a comma in there.
That's what we had. That's what 5 That's what 5 originally was before.
I see what you're saying. Yeah, because it can go either way. You can go start in scientific notation, and they'll ask you to do it in standard form, or you're in standard form, go to scientific notation, and that's what these 8 are talking about. This is standard form. Yep. All right, number 6. We have 4.04 times 10 to the 2. Here's where my decimal was. It's going to move over how many spots? 2 to the left or the right? Right. Because whenever you're going from standard notation, from scientific notation, if this is positive, it's like a number line, it goes to the right. If that were negative, it would be going to the left. Okay? So now my new number is 404. File not found, or website not found. Here's one with a negative. I'm going to have 4 here. My decimal place is going to be moving. See how this is negative? So I'm going to be going up like on a number line. Negative is to the left. My decimal point was here. I'm going to go 1 and 2. Here's my new decimal point. I need to put a 0 as a placeholder. My answer is 0.4. And I'm going to put 0.04. So I want to have that ones digit represented. So how come you're the only one not writing down stuff? Right away, I see a negative symbol here, so I know that I'm going to the left. Beautiful. I'm going to the left. So I'm going to rewrite this number, which is my parents' address and where I grew up, the 637, North Lisle. Here's where it was. I'm going to the left, so it's going to be 1. I'm going to do it, yeah. And 2. I have a placeholder there. Oh, whatever. I didn't mean to do that in highlighter, but you guys know what I mean. 0.0637. Any questions on that? You did a lot more work than what? Yeah. Well, he's gonna fully explain it. That was a 20-minute video, and we just did this in 5 or so. You know. It was 10. That was 3 minutes long. That whole lesson. So once again, this is how we did it. Whenever we're going from scientific to standard, we look at the exponent and see whether we're going left or right, how many decimals a place goes. When we're going the other way around, which is a little bit more challenging, we are going to make sure that we have a 1 in the 1 digit in the ones digit. Yeah, that's what I meant to say. You need to make it so it's something point blah blah blah. Any questions on those two ways of doing that? Okay. Which one do you want to see? Yeah.
Oh, I was looking at the right exponent.
Cool. Now that we see how to recognize them, let's talk about adding and subtracting in scientific notation. This is adding and subtracting in scientific notation. And you won't have to write down everything that this PowerPoint says verbatim, which means word for word. You do not have to do that. And we probably won't even get through this, but adding and subtractions, the exponents must be the same. Make sure you write that. Exponents must be the same. If the exponents aren't the same, you have to adjust it so they are. And we just learned how to adjust them. Sorry. If the exponents are not the same, it's necessary to change one of the numbers so that both numbers have the same exponential value. Yes? It can be a negative exponent, but as long as you're adding and subtracting one that has the same negative exponent. For example, if I had 4.53 times 10 to the negative second plus 4.55 times 10 to the negative 4, we need to make sure that both of those exponents are the same. But that's just the first slide, and you'll see what I mean by it, okay? You can have negative exponents. So you don't have to write that whole thing, but you do have to say exponents must be the same. You must change them if they're not. Okay, change them if they're not. Okay. So the general format for adding is, and let n be a number, n times 10 to x plus m times 10 to x is n plus m times 10 to the x. So please rewrite that formula. Please rewrite that formula. And rather than the x, can you guys make that a multiplication dot? So it's going to look more like this. I get a multiplication dot. So you're not confused. Oop, that's not that program. Not too much. Yeah. Oops. Yeah. N and M be numbers. N times 10 to the x plus m times 10 to the x is equal to n plus m times 10 to the x. The first step, if necessary, is to change the number, one of the numbers, so that both numbers have the same exponential value. So you need to have it be those x's that are up there, that exponent needs to be the same number. As Len was asking a second ago, he said, can it be a negative? Yes, it can be a negative exponent. It just has to be the same exponent before you can do anything with it. Oops, hello. Oh, do I have to go up there? Go away, keyboard. I do. Rats. Okay. Yep, we have a couple minutes. Just trying to make the most of what you got. Adding. Second, add the coefficients. The coefficients, those are the n and the m of the formula that you just did. A coefficient is something that is going to be in front of what you're, it's going to be multiplied by both things, I guess you could say. That is a better definition when I show it, but And the final step is to multiply the result by 10x, 10 to the x. Yes?
Are these notes going to be on your webpage?
Yes, this video and this PowerPoint and the little CUDA worksheet that we did at the beginning together, that will all be on my website. So the final step is to multiply the result by 10x. Yes?
What if the exponents are the same?
That's why you have to change them, and that's what we're going to get to. Yep. You move the decimal point in one of them, one way or another. That's what we're trying to do. This is just showing you what to do. It'll be clear when we actually do it. I promise. Adding with the same exponent. Adding with the same exponent. So we have 3.45 times 10 to the third, or 10 cubed, plus 6.11 times 10 to the third. So all we have to do is we just have to add those two decimals together because they have the same exponent of 3. And we get 9.56 times 10 to the third. We can do this because this is the same as this. So all we need to do is just add the coefficients. Here's the coefficient for the first one. Here's the coefficient for the second one. Yes, sir?
Well, that's not the final answer.
The final answer is right here. That is simplified. Scientific notation is simplified. That is solved. Because all you're doing is just adding zeros to it. That would be 9,560, that sort of thing.
Oh, so you just need, if they have the same exponent, you just need
Yep.
until you get the final.
Until you get the final answer. You're correct. And it'll tell you every question. It'll say, write it in standard notation or scientific notation.
That's the answer.
That's, yes. Now here's a situation where the exponents are not the same. They are not the same. We have an exponent of 6 here. Use green. Here's an exponent of 6. Here's an exponent of 4. We have to have them be the same thing. Now, what we're doing with this guy, and that doesn't really explain that very well, but I'm going to go ahead and show you. 412 times 10 to the 6th. We want that to be times 10 to the 4th. So in order to do that, I'm going from having 6 zeros, or having 6 more decimal places to add to the right, I'm going to go to having 4 zeros. So when I go to the right, 2 of them, 1, 2, and when I go to the right from what we did at the beginning, does your exponent get higher or lower? Lower. So now I have 412 times 10 to the 4th. And then since I have the same exponents, now I can add those together. 412 plus 394, or 3.94. Line up the decimals like you learned last year. And our final answer is going to be expressed in proper form. This is not proper form because we don't have just one digit in front of the decimal. Yes, sir?
So once you change it, instead of just moving it to remembering how many places you moved it back, you can just make it so only one digit is last.
Yeah, you could make the 4 a 6 as long as you have them both be the same. That's a good question. I could have gone the other way with this, where I made this guy a 6, which means that I would have gone to the left. So it would have been 4.12 times 10 to the 6th plus 0.394 times 10 to the 6th. No, I didn't go far enough. Yeah, didn't go far enough. Should have gone to 0.0394.
Good morning. It is now time for students to go to their 7th hour class. Thank you.
Does anybody have Goose's contact information? Okay, tell her that we didn't get to that homework, if you wouldn't mind. Bye. Have a great weekend. Okay. I will give you the homework then.
You're the only one that believes in yourself. You're the only
Nope.
person that shouldn't believe in yourself.
All right. That's enough of that.